So guys, in this video, we're going to talk about chain rule. That is continuation of Math 252 multivariable calculus. So at the end of this video, you'll be able to use case 1, case 2, case 3 to solve for any function given to you using chain rule. So let's look at case 1. So with case 1, what you must do is that they're going to give you a function in terms of x and y. And in this case, another function will be given to you in which the variable of x also will be given to you in terms of t. So in this case, they gave you that z is equal to f of x and y, whereby x is also equal to a function of j in terms of t, and y also equal to a function of h in terms of t. So in this case, they're going to give you three functions. Yes, and they will ask us to compute the z over the t. In this case, let's see how we're going to do it. So this is what I'm going to explain this for you. So for this one, for us to find the z over the t, what you must do is that you take the function of z, this function, and partially differentiate it with respect to x. Partially differentiate it with respect to x, and take this function of x, partially differentiate it. This one we're not going to do partial differentiation because we're going to differentiate it, no partial differential. So differentiate this function in terms of t with respect to it. So you are doing it the function of x in terms of t, the x over the t. Then plus, you're going to take the same function of z, then you partially differentiate this in terms of y, times you take this function of this y and differentiate it. So with this, you are going to solve one example for you to understand. So this is the formula that is important. This is f of x dx over dt plus f of y dy over dt, because they're going to give you three functions, which is the main function whereby you're going to differentiate it partially with respect to x and y. Then they'll give you that x is equal to a function in terms of t, and y also is equal to a function in terms of t. So then let's take some example. So what I was saying is this. So in this case, they gave us the main function, which is z is equal to e, that's x times e exponent xy, and they give you that x is equal to t squared, then y is equal to t exponent -1. So in this case, for us to find this one, this is case 1. You being able to identify the case will help you solve the question. So in case 1, you're going to get three functions, which is the main function, then they're going to give you the variables given to you. You're going to take that function. So in this case, we have how many variables? We have two variables, x and y. Then we are going to take x to be equal to another variable, which is t squared. And they are going to take the y to be equal to another variable, which is also in terms of the same t. So this is how you must know that this is case 1. And with case 1, as we've established by the formula, you know that the z over the t will be equal to what? The partial derivative of this function, then times the x over the t. You are differentiating this with respect to t. So this is what you do. Then plus, you differentiate this partially with respect to y, and do it this one with respect to t. So when you do that correctly, when you partially differentiate it with respect to x, this is product rule, times the x over the t will be what? 2t. That's what we have here. Then plus, partially differentiate it with respect to y, times this will be what? -1. That's negative t exponent -2. And you get that. So that's for case 1. Very simple as that. So in case 1, for us to go, the review of case 1 is that they're going to give you three functions. That is the main function in terms of two variables. Then they're going to take that variables and equate it to another variables. In this case, the variables of x and y should be the same, as in they are all in terms of t. That's what you need to know by case 1. Then you take the formula that partially differentiate this with respect to x, then you do this the x over the t. Partially differentiate it with respect to y, we do this the y over the t. And in this case, the variables can change. This can be maybe xz. That means that they're going to give you x is equal to this and z is equal to that. So when you are solving that, you need to know how to input that when the variables change. So at the end, you're going to get this. It's very simple. Now let's note this. In this case, this is another case, right? I think let's assume that this is case 2. So in case 2, they're going to give you two functions. So they're going to give you a function in terms of x, z, not always in terms of z. Then they're going to give you a function in terms of either one of them, whether x or y. So in this case, from the formula here, asking us to find the x the z over the x, what do? It's very simple. You partially differentiate it with respect to what? X. Then times, since we don't have a function of x here, you're going to, the x will cancel the x, making it 1. That's why they had 1 here. So when they give you two functions and you look at the functions, sometimes they can give you x and y will not be given. Therefore, y will also be equal to 1. So you should know the difference. When they give you two functions, you just do it normal way. But in this case, we don't have x being equal to a function of something. And here, note, the y is equal to a function in terms of x. So then when you are doing that, that will be what? Dy over what? Dx. As I told you, not always t will be given. But in this case, they gave only two functions, and x was not given to be equal to a function of x, because it cannot be equal to a function of x. S being equal to, like you get x is equal to 2x. It can't be possible. Therefore, the dx over dx becomes what? 1. You understand? So let's take an example from here. This is what I was talking about. They gave us z and they gave us only y. We don't have x. So therefore, what you are using is that you're going to do what? The partial derivative of this in terms of x, then plus the partial derivative of this in terms of y times dy over dx. Very simple. When you solve it, this is what you're going to get. As it's very simple as that. Let's go to the case 2. I normally call this case 3 because the other one is case 2. So let's go to case 2. Don't mind me. So in case 2, this is a case that they will give you three functions, but in the three functions, the variables in the functions given to you will be in three, maybe in 2 or 3. Let's assume that this is the main function given to us, right? Yeah. Then they are going to give us the x is equal to a function in terms of what? S and t. Y will be equal to what? Also be given to us a function in terms of what? X and t. So in this case, they can answer to find the partial derivative. The partial derivative of what? Z in terms of x. So in this, what you must do that we are dealing with what? The x value, right? So what are you going to do? You take this partially differentiative in terms of what? X. Then you go to the partial derivative of x. And in this is partial derivative because the variables is in terms of multivariable. This is multivariables, right? So you cannot use differentiation, right? So then you're going to use partial derivative because it's in terms of two variables. So you need to know that in two variables you use partial differentials. So this, they've given you that x is equal to a function in x and t. So you take this, you partially differentiate with respect to x. Then you come here, since you are finding the z over the x, always note the denominator. You are going to partially differentiate this function in terms of what? X. Then plus you partially differentiate this in terms of y, and then partially differentiate it in terms of what? X. The same thing applies because it involves two variables, which is x and t. So when they ask us to find the partial derivative of z in terms of t, that means we're going to take the function, the whole function, that is a z, partially differentiate in terms of x. Then times, you come to the x, partially differentiate this function in terms of t. Then you go to plus, you partially differentiate it in terms of y, times, you partially differentiate it in terms of t. This is very simple for you to understand. This is very simple. It's not for you to take the formula in your head. You need to understand the concept behind this. That from the previous one, we only deal with one and that one they asked now to find the z over the x. So the partial derivative is because the function given to us is in terms of two variables. That's why you're doing partial derivative. But with case 2, in this case I call it case 3, the functions given to you, both of them have two variables. So then you need to use partial derivative for both of them. That's why we use partial derivative for both of them, right? Let's take some example here. They gave us z is equal to this, r is equal to this. Look at this. In terms of that, for you to understand, first you need to identify the variables. We have s and t, and we have r and theta, right? So in this case, they asked us to find the z over the x. So you come here, the z over the x, you partially differentiate it in terms of what? X, right? In terms of r, partially differentiate it in terms of r. Then you come to the r over what? The x. So let me write this for you. You partially differentiate this in terms of r, then times partial derivative of r in terms of what? X. Very simple. And the second one, the x, the z, that's the partial derivative of z. The partial derivative of the z function in terms of t. You are going to take this, that you partially differentiate this in terms of what? theta. So that will be partial derivative of this in terms of theta, then times partial derivative of the theta in terms of what? In terms of t. Very simple. That is very simple. Very simple, and it's easy for you to understand. If you don't understand again, just go to the explanation I explained, and I think you will understand from here. Simple. You always look at the denominator. This you are finding the z over the x, partial derivative of the function z in terms of x. So in this case, you come here, you partially differentiate this in terms of r times the partial derivative of r in terms of x here. So what will you get here? Here you're going to get what? T. Because you're going to get t. That's why they had t here, right? You're going to get t. And here in terms of r, you're going to get 2er sine 3 theta. That's what they had it here. And then you come back again plus the partial derivative of this in terms of theta. You do that. Then you come and take this side times the partial derivative of theta in terms of what? S. And you do this. Very simple. So with the chain rule, case 1, case 2, case 3 is very simple for you to understand. And it's not for you to keep the formula in your head, but understand the concept and you'll be good with it. So thank you very much for watching.